An asteroid colliding with the Earth is the stuff of science fiction. Several movies and books are based on or attempt to stop the idea. But an asteroid colliding with Earth isn't just science fiction, it's also science fact. NASA's Jet Propulsion Laboratory in California has an asteroid watch program whose sole purpose is to detect and track asteroids and comets that the agency believes will approach Earth. But what would happen to the environment if the Earth collided with a large comet? What, for example, would the climate be like afterward? And what kinds of life would most likely to survive? Welcome to a new episode of Imagine That. Hope you're doing well. Today we will discuss imagine that our planet is hit by a large meteorite. Before we start, make sure you hit that subscribe button with notifications turned on to get notified when we update videos like this one. Let's get into the world of imagination. Asteroid Watch. On the Asteroid Watch dashboard for December 2022 alone, there were 5 asteroids, 2 of which were thought to be the size of a commercial jet. Earlier this year, NASA named an asteroid 1994 PC-1 that was 2.5 times the height of the New York City's Empire State Building. It flew by Earth for the first time in 200 years on January 18, 2022 at a safe distance of 1.2 million miles. However, not all asteroids have missed Earth throughout history. There are visible craters on Earth and the Moon that demonstrates a long history of massive objects colliding with the planet. The most famous asteroid in history is the one that collided with Earth 66 million years ago. The mountain-sized asteroid created a crater 93 miles wide and 12 miles deep off the coast of the Mexico's Yucatan Peninsula. Scientists believe it caused massive tsunamis, threw so much water and dust into the atmosphere that it blocked sunlight, lowered global temperatures, and wiped out the dinosaurs. What would happen if an asteroid hit Earth today? Asteroid collisions are extremely unlikely. NASA has tracked 90% of the near-Earth asteroids that are at least a half-mile wide, believes that none of them pose a significant threat to Earth. Still, there could be some larger asteroids out there that NASA is unaware of. A mile-wide asteroid would strike Earth's surface at approximately 30,000 miles per hour. An asteroid that's large, traveling at light speed, has roughly the same energy as 1 million megaton bomb. It's difficult to imagine 1 million megatons, so let's start small. Assume an asteroid, the size of a house, collides with the Earth at 30,000 miles per hour. It would have roughly the same energy as the Hiroshima bomb, perhaps 20 kilotons. An asteroid of this size would flatten reinforced concrete buildings up to a half-mile away and wooden structures up to 1.5 miles away. In other words, it would cause significant damage to any city. If the asteroid was the size of a 20-story building 61 meters on a side, it could have the same amount of energy as today's largest nuclear bombs, between 25 and 50 megatons. This asteroid's size would flatten reinforced concrete buildings 5 miles from the epicenter. Most major cities in the United States would be destroyed. A massive asteroid would be required to wipe out almost everything on Earth. It would take an asteroid 7 to 8 miles wide to crash into the Earth, according to scientists. Once it collided, it would create a massive dust plume that would cover the entire planet, blocking out the sun and raise temperatures where the asteroid collided. Billions would perish. Much of the planet's life would be destroyed. Scientists believe that some would survive. According to NASA scientists, it would take an asteroid 60 miles wide to destroy life on Earth. The effects of an impact on Earth are highly dependent on the size and thus the energy of the impact. A comet less than 100 meters across, for example, will likely explode high into the atmosphere and cause no harm. If the comet is 10 kilometers across or larger, that is, if the impact has an energy of more than 100 miles megatons, the resulting global environmental damage will be so severe that much life forms will perish. This is what happened 65 million years ago at the end of the Cretaceous epoch, when dinosaurs became extinct. The environmental consequences of a massive impact are numerous. The worst effects are a global firestorm, ignited by backfalling impact debris, and a global pall of darkness that lasts for months due to dust suspended in the stratosphere. Imagine a collision between a comet and Earth would be disastrous. According to the best available computer simulations, the impact of a kilometer-sized or larger object would most likely result at the end of civilization. Such a body would not annihilate our species if the incoming object was larger than about 5 kilometers in diameter. Homo sapiens would be very unlikely to survive. In general, the initial impact creates a massive fireball that kills anyone who sees it. In the aftermath, the material is thrown into the air from the impact blast into space, showering a large area with flaming debris, possibly half of the world. A similar effect was observed when comet shoemaker Levy 9 collided with Jupiter in 1994. The sky fills up with billions of meteors, a shower of particles that burn up in the atmosphere as they fall. It's as if the sky was caught fire. The heat released by this incendiary rain ignites forests and cities, reducing them to embers. Then, dust from the impact and smoke from the fire girdle the Earth, plunging our planet into what is known as an impact winter. After a collision with 1 kilometer object, sunlight disappears for about a month. A 10-kilometer object may block out the sun for a year or more. Temperatures plummet, and there is no light to support photosynthesis. Plants and animals both die. Animals that live underground, where their roots and other food sources are not destroyed, have a better chance of survival. The comet is blown to smithereens during the impact. It generates billions of tons of sulfur-laden dust, some of which is emitted by the comet, some of which is emitted by the sulfur-rich rocks that may lie beneath the impact point. Nitrogen oxides are also produced by the impact's heat. Acid rain enters the oceans and kills marine organisms, particularly along continental shelves. The initial blast release of the nitrogen oxides and debris into the stratosphere would destroy the ozone layer within days. The impact and subsequent fires also emit a massive amount of carbon dioxide into the atmosphere. After the initial impact, there is so much carbon dioxide in the air that a centuries-long greenhouse effect may occur. Scientists are still debating whether the object that struck the Earth 65 million years ago was a comet or an asteroid. In any case, the consequences were so dire that it's a miracle any species survived at all. However, some did. After the dust settled, they emerged to spread across the newly formed world, multiplying and finding new niches to fulfill their destinies. Certainly, the impact of a large meteorite on Earth would be determined by several factors, including the size, speed, angle of impact, and location of the impact. However, if a large enough meteorite were to strike the Earth, it would have disastrous consequences for the planet and its inhabitants. The immediate consequences would be catastrophic, with widespread destruction and massive tsunamis, fires, and earthquakes. The impact could also cause a large amount of dust and debris to be released into the atmosphere, blocking out sunlight and causing a prolonged period of darkness and cooler temperatures. This would result in a global cooling event, which could disrupt the food chain significantly, potentially leading to a mass extinction events. There should be significant social and economic disruption in the aftermath of the impact, especially if the impact zone was densely populated or caused damage to critical infrastructure. Authorities would need to coordinate a massive relief effort to provide those affected with emergency supplies, medical care, and shelter. Scientists and authorities are developing detection systems and plan to track and redirect the trajectory of near-Earth objects to receive the potential impact of a large meteorite. The Near-Earth Object Camera is one such system, which is designed to detect and track near-Earth objects. Another method is to use gravitational attraction to deflect a meteorite's trajectory while launching a spacecraft to intercept and redirect its way from the Earth. Scientists and authorities are constantly working on developing detection systems and plan to track and redirect the trajectory of near-Earth objects in order to mitigate the potential impact of a large meteorite. However, much work remains to be done to safeguard our planet from potential cosmic threats. In conclusion, while the possibility of a large meteorite colliding with Earth is remote, it's a possibility that requires constant monitoring and planning. Governments, organizations, and individuals must remain vigilant and take precautions to mitigate the potential impact of such an event. That's all for today. We hope you liked this video. Let us know in the comments. What would be the long-term effects of a large meteorite hitting the Earth? And how would they impact human civilization? See you in the next video. Please subscribe to our channel and press the bell icon to get new updates.